The construction industry generates nearly 40% of all global carbon emissions. Every material we pull from the earth and stack into our skylines carries a mounting environmental debt. Current internet trends often present a simple solution through aesthetic listicles. These digital guides promote materials like cross-laminated timber and Hemcrete as universal, sustainable fixes for every building project on the map. But high-end architectural trends can be misleading. What works structurally for an 18-story Norwegian eco-tower often wastes considerable money and resources when applied to a standard 2-story home. Evaluating a material requires looking at embodied carbon. This is a metric representing the total greenhouse gas emissions generated to extract, manufacture, and transport a material before the building is even occupied. This data reveals a sharp contrast in the insulation market. A standard polyurethane slab carries a high price point and carbon load, while an option like sheep wool provides a significantly lower carbon footprint. To build sustainably, we must strip away the architectural marketing. Sustainable construction requires analyzing actual structural realities to prevent the trap of overengineering. The most effective green choice matches the structural demands and physical scale of the project itself. Cross-Laminated Timber, or CLT, currently dominates green architecture headlines. CLT consists of lumber boards stacked at perpendicular angles and glued together, creating formidable structural strength. For mid-rise commercial buildings, CLT offers rapid on-site assembly and a substantial capacity to store carbon absorbed during the growth of the trees. However, the efficiency of CLT vanishes when applied to a standard 1 to 3-story residential home. Because CLT uses stoled panels, it requires 30 to 50% more wood, creating a 20 to 30% cost premium for unnecessary capacity. Standard timber framing remains the efficient choice for smaller builds, using wood only where necessary, leaving wall space for lighter, cheaper insulation. Paying for unnecessary capacity wastes your construction budget and the forest resources you intended to save. Beyond the frame, we must consider the building's envelope. Eco-blogs frequently highlight Hempcrete as the peak carbon negative choice. Hempcrete is a composite of hemp fibers and a lime binder. It petrifies into a stone-like material that actively sequesters carbon dioxide from the air. Despite its density, Hempcrete has a major structural limitation. It cannot bear weight. On a job site, Hempcrete requires a secondary timber frame. It also introduces long curing times that can stall construction schedules while the material hardens. This chart maps building envelopes. Hempcrete sits bottom left, achieving negative carbon emissions but zero load-bearing capacity. Sheep's wool and cork sit similarly, offering breathability but requiring moisture risk modeling. Recycled PET bottles cost less but are less thermally efficient, requiring thicker walls. Selecting an envelope material determines your construction timeline and wall thickness. You must choose between achieving peak carbon reduction and maintaining a practical installation schedule. On the exterior skin, natural clay and slate roofs offer significant historical and environmental appeal. Slate and clay last a century while providing natural insulation. At their life cycle's end, they return to the earth as zero landfill waste. However, natural stone is incredibly heavy. Supporting a slate roof requires reinforced roof trusses and a much higher upfront investment in the building structure. Modern composite roofing provides a lighter alternative, manufactured from 100% recycled plastics and rubber. These composites mimic slate's durability at a fraction of the weight. The trade-off is relying on an industrial recycling loop rather than natural biodegradability. Interior finishes face similar trade-offs. Low VOC paints reduce harmful airborne chemicals. Natural lime and clay plasters go further, providing active health benefits by regulating indoor humidity between 40 and 60%. However, these natural finishes require specialized artisan labor, significantly increasing interior costs. The building's skin is where builders face the highest tension between aesthetic desires, long-term health goals, and strict budget limits. Successful sustainable construction requires aligning a specific material stack to a project's mission. The first profile is the pragmatic retrofit. This builder is primarily constrained by a tight budget and a limited timeline. Pragmatic builders should prioritize standard timber framing and recycled synthetic insulation. This approach skips the cure times of Hempcrete to efficiently reduce the building's operational energy. The second profile is the deep green custom build. which prioritizes occupant health and carbon neutrality above all else. Deep green builders must accept a 20% cost premium and a longer project timeline to accommodate specialized eco-contractors and natural materials. The final profile is the scalable developer, managing multi-story projects. Mid-rise commercial builds are the appropriate home for CLT. Developers trade heavy upfront engineering costs for rapid on-site assembly and the ability to span large structural distances. The greenest possible building avoids overengineering. True sustainability is achieved only when the inherent strength of a material perfectly matches the reality of the project.